Hello and welcome to a new video lecture. In this lecture we are going to review tensor decomposition techniques and applications as published by Tamara et al. Tensor decomposition is a family of methods that decomposes a high-dimensional tensor into two-dimensional matrices. This is desired for dimensionality reduction, faster computation, and it finds many applications in both machine learning and IoT. The first method is CP decomposition, where CP stands for canonical decomposition parallel factors. Given n-dimensional tensor T, which is a tensor of real numbers with dimensions d1, d2, up to dn, the CP method finds n two-dimensional matrices, each of dimension d of I by r, for all I in the range between 1 up to n. In this case, R is a predefined input that determines the dimensionality of the resulting matrices. R is a parameter that can be optimized using grid search and cross-validation. The best R is the one that minimizes the reconstruction loss between the original tensor and the reconstructed tensor from the decomposed matrices. CP is best visualized in case of a three-dimensional tensor by decomposing it into the summation of relevant vectors from 2D matrices. Hence, this diagram explains how each element in the three-dimensional tensor is computed from the vector product A1 by B1 by C1 up to R times. This method is time-consuming and requires iterating over the rank R parameter to find the optimal value. Analytically solving tensor rank is NP hard intractable problem. That is, it can't be solved unless P equals NP, which is a topic very famous in computational complexity. Another method is Tucker decomposition, which factors n-dimensional core tensor and n unitary matrices that has a desired property. A unitary matrix is a matrix whose inverse is equivalent to taking the conjugate of its transpose. In this case, we have got more sparsity, more zeros values instead of a dense matrix, and at the same time we have preserved the reconstruction error to be minimum. Here we have got a visualization of the decomposition of a three-dimensional tensor into three unitary matrices and a three-dimensional core tensor. This method has proven to be faster and achieves less reconstruction loss compared to CP decomposition. Thank you and see you in the next lecture.